Hello everyone and welcome to the 50th question of mathematics. So for this video, we'll focus on chapter 5, probability distributions. Let's aim ourselves to learn one thing from this video. Alright, so I'll let you have a few seconds to go through the questions first. Alright, so for part A, we have this study whereby this delivery service has 2% of the packages being late. Right? So from this study, we need to state the type of the random variable and we need to give our justification, which means we need to give a reason lah. So for random variables, we actually have two types. So one is discrete and one is continuous. So discrete means countable and continuous means uncountable. Right? So the examples are, so for discrete, it will be number of students in the class. Okay, let's say a number of students in the class, there are 4 of them, maybe 5, maybe 6. So these are countable. Okay, there will not be a situation where there are 3.5 students. Does make sense, correct? So number of students are countable, which means they are discrete. So for continuous, they are uncountable. Example is height of a student. So you all may be wondering, actually I can calculate my height. Maybe my height is 170 cm. But if you want to find the accurate height, it will be difficult. Because your height may be 170.14, 170.142. So the accurate value we don't know. So this quantity cannot be counted. Right? So this will be under continuous. So going back to our question, the number of packages that are late can be counted. Okay, so maybe the possibility is maybe 0 of them are late, maybe 1 of them are late, 2 of them are late, 3 of them are late, and so on. So there will not be any possibilities whereby there are decimals. Let's say 3.5 packages. Right? So here it will be a discrete random variable, and we can say that its values are countable as our answer. Alright, so for part B, we have a jewelry store whereby 7 customers, 2 of them bought jewelry on a certain day. So if I randomly select 10 customers out, we need to find the probability that exactly 4 of them bought jewelry, and another case is at most 2 of them did not buy jewelry. Right, so for this chapter, if you want to find probability, we need a random variable first. Okay, so random variable is actually an unknown. So I can let this definition of this unknown to be this. Okay, number of customers that bought jewelry. Alright, so here our random variable needs to follow a distribution. Okay, so let me change the color of the pen. So X will follow. So this curvy line is follow. So in this chapter, you all learn these two distributions. One is binomial and one is normal. So for this case, binomial will be more suitable, right? Because for binomials experiments, there will only be 2 outcomes. Okay, so example, heads or tails, true or false, or success, failure. So in the context of this question, it will be bought jewelry, did not bought jewelry. Right? So here we can follow binomial, so it's B, and for binomial we need 2 information. So the first information would be number of trials, or N. Okay? So going back to the question, we randomly selected 10 customers. So this means that I chose one customer and I determine this customer, did he or she bought or did not bought jewelry. And I choose another customer out, did bought or did not bought the jewelry. Okay, and we repeat this process by 10 times. So here it will be 10. Okay, and for the probability of success, so success actually depends on our definition. So if here we says that the customers that bought jewelry, so our success would be those who bought jewelry. So the probability that they have bought jewelry would be from this sentence, 2 out of 7 customers that bought jewelry. Okay, so this is our probability, 2 over 7. Okay, and now we can find the probability for part 1. So here says exactly 4 of them. So we need to find the probability. So P is probability. So our X must be equals to 4. 4 customers that bought jewelry. So here we can use this formula. So here, this part means out of 10 of the customers, 4 of them has bought jewelry. Okay, and now we need to multiply the probability of those who bought jewelry. So the probability is 2 out of 7, and we need to multiply 4 times. And we need to multiply the probability that the customers did not buy jewelry. So it's 1 minus 2 over 7. So the formula for Q is actually 1 minus P. Okay, and we need to multiply 6 times because there are 6 customers did not buy jewelry. Okay, or you can calculate from here, n minus r is actually 10 minus 4. Okay, so your answer will be 0.1859. And for part 2, we need to find at most 2 of them did not buy jewelry. So here's a little bit different with our perspective. Our perspective is we have bought jewelry, but the question's perspective is did not buy jewelry. Okay, so now we need to change this perspective to our perspective. Okay, so now the solution can be, I will draw out a table first. So here I will write did not buy and our perspective, which is buy. Okay, so now I list out all the possibilities first. So here it says at most 2 of them, so this means it will not exceed 2. So it will be 0, 1 and 2, which is our possibilities. And now from each of the possibility, I will just try to calculate for each of the possibility what is the number of customers that bought the jewelry. Okay, so the first one will be 0 customers did not buy. So this means all of them bought. Okay, if 1 did not buy, means 9 bought. If 2 did not buy, means 8 of them bought. Right, so here means that we need to calculate the probability where there are more than or equal to 8 customers which bought the jewelry. Okay, so our probability would be Px is more than or equal to 8. And we need to calculate the probability for these 3 cases. X equals to 8, X equals to 9, and X equals to 10. Right, so for this part, it's actually the same as part 1. We just use this formula and we depend on the value 8, 9, and 10 and we sub in the values. Okay, and our answer after adding all these probabilities would be 0.000111 in 4 significant figures. And with that, we have completed today's question. Alright, so here's the take-home point for this video. So for binomial distribution, if we want to find probability, we need to set our random variable first, and we need to set the definition. Right? So let's say it follows binomial, which is B, and it needs to have 2 information. The first information would be the number of trials. The second will be probability of success. So success here depends on the definition of your random variable. Right? And the second thing we need to know is that there will be, this is quite a common question in SPM, which means the question's perspective and our perspective might be different. Okay? So what we need to do is we need to change the question's perspective to our perspective to accurately find the probability. Alright, so here's the answer scheme for this question, and hopefully you have learned something new from this video. So if you feel this video is beneficial to you, please give it a like, subscribe and share. So thank you so much for watching, and I'll see you all in the next video. Bye bye.